we'll just start waiting till we're all quiet. We have a habit of having 8-side conversations in this class. There we go. Okay, so we want to be able to use our derivative tests to be able to learn information about functions and their behavior. The first one, I do not have a derivative. I have the actual function. So we're going to be showing you first derivative. We're going to be showing you original graph. We're going to be showing you second derivative. And we have to try to glean information about that to determine things about the function. So as we look at this function here, this is the function. Over what intervals do you feel like this function is increasing? This is the misconception, okay? So you guys are absolutely right in kind of what you're thinking and you're saying, but you're applying them to two different situations. Notice that what we said was true about increasing is where f prime is greater than 0. Everybody agreed? So if I'm looking at f prime, I'm looking where the function is above the x-axis, right? Is this f prime? No. So I'm just wondering, when is this function on its way up? Yeah, from negative infinity, negative 4. See that? So you're looking at the original function. On the AP exam, 90% of the time, they will give you f prime. They won't give you f. Sometimes they'll give you f double prime. Sometimes they'll give you the original function. You must look at which one they give you and then determine accordingly. So we are on our way up from negative infinity to negative 4. Where else are we on our way up? 0 to infinity. So therefore, I'm on my way down from where to where? Yep, so I'm going to draw that in red. From negative 4 to 0, it looks like I'm on my way down. And now, I'm going to skip the concavity. I'm going to move to local min and local max. I can see where the local max occurs. What is the coordinate for the local max? Negative 4, positive 1, I have a local max. I have a local min that occurs at, good. I would like you to have a conversation with the person next to you and see if you can determine the interval for concave up, the interval for concave down, and the point of inflection. If you don't think you can say it exactly, try to estimate it. Talk to the person next to you. Go. Okay, let's see what you got. Okay, eyes up here. This is what I would encourage you to think about. As I draw this green part of the graph, I'm going to say that that's approximately when it's concave down. And then in the black part of the graph, I'm going to say that's approximately where it's concave up. Are people okay with that? That estimation. So I would say I'm concave down from negative infinity to about negative 2. And then concave up from negative 2 to infinity. The point of inflection is where it changes concavity. And if I can demonstrate here by just simply using this pencil, notice what's happening to the slope of this line as I continue to move along. What's happening to the slope? It's continuing to decrease until we get to that point of inflection. Then what happens to the tangent line? Then it starts going back up again, right? So that's what we're looking for when we say inflection, and I'm going to estimate it happens at negative 2, negative 2. Are there any questions about that graph right now? Now we're going to switch it. We're going to do kind of what we've been doing, which is we look at that first derivative. What does the first derivative tell us about? Have a conversation with the person next to you. Which one of these do we use the first derivative for? Talk, see if you can figure out. Which ones do we use first derivative for? and stop. Eyes up here. What I need you to be able to do on the test is I need you to be able to take a first derivative and know that you're going to identify increasing and decreasing and be able to identify local max and local min from those. Those are our first derivative tests. So when the first derivative is greater than 0, it's increasing. So look at, I gave you the same shape, but this one happens to be f of x, so this one is f prime. So I'm wondering, where is f prime greater than 0? I'm looking for where it is above the x-axis. So when it says increasing, I'm wondering, these are all characteristics of f. True or false? You know exactly what the graph of f looks like. You do? I don't see it. What does it kind of look like? Okay, so you can glean information about this to try to reconstruct it. Okay, so I can see that, but this tells you about the graph of f. So the graph of f is going to be increasing from what to what? Because that's where it's above the x-axis. Where else is f increasing? Good. All right, where is f going to be decreasing? Negative infinity, negative 5. Yep, negative 3 to positive 2. And that's it. Local max and local min occur when, so local max occurs when f prime changes from positive to negative. Local min occurs where f prime changes from negative to positive. We can only identify the x values. Because we're given f prime, we don't know what the original function is, so we can't plug that into anything. But what is the x value where we have a local max and local min? Talk to your partner, see if you can figure it out before you answer me. Go, see if you can talk. Five, four, three, two, one. Okay, local max. Can somebody tell me what's the x value? Negative 3, because that's where it changes from positive to negative. Excellent. Okay, can we get to Bree's question here, because it's a really good question. She says that she's used to writing a y value as well. Once you identify the x value, to come up with the y value, you plug it into the original function, didn't you? Do you have an original function that you know the equation for? You don't. So we can only identify the x value. We don't know the y value. See the difference? So that's something that will happen on your assignment today. You won't be able to produce that y value. Just state the x value in that scenario. All right, local min is where it changes from negative to positive, which would be negative 5 and positive 2. Great. And so here's where people start to kind of lose some of their confidence and their understanding is when we start to look at the second derivative. So concave up and concave down, that's where f double prime is greater than 0 and where f double prime is less than 0. Okay, so as I look at f prime, the question is, what does f double prime look like? I'm going to bring you back to this. If this is the original function, would you agree that a tangent line represents the first derivative? That a tangent line is the derivative of the original function. So in this situation, you have f prime. So a tangent line is going to represent the second derivative, right? So tell me something about this tangent line. The slope is positive. Everybody agree? So that means the second derivative is positive at this spot. Tell me something about the tangent line here. Slope is negative. So therefore, the second derivative is negative here. And then here, the slope is 0. So the second derivative is 0 at this spot. Okay? So let's start with inflection. Inflection is where it changes sign. F double prime changes from negative to positive or positive to negative. So F double prime is positive. Here it's, so where does it change sign? At -4. Where else does it change sign? At 0. So therefore, it's concave up whenever the second derivative is negative. When is the second derivative negative? Or I'm sorry, second derivative positive, excuse me? Where else is the second derivative positive? 0 to infinity. And so it will be negative in between. So I'm not going to lie, okay? This is one where you start working on that assignment. Don't be surprised. I would say generally about a third of the class has follow-up questions on these graphs, okay? You're going to see them multiple times. We will do a checkpoint on it to make sure people are good. We're going to do one last one here, and I want you to draw this graph. What's that? No, they're already there for you. Okay, why don't you mark these points, okay? Mark -3 and +4 on the x-axis, and then plot the coordinate 1, -4. And I'm going to draw this graph right here. And we're going to talk about F double prime. I've now given you the graph of F double prime. That's the only thing that we have. We don't have F prime. We don't have the original function. Does F double prime, does that tell us about increasing and decreasing? So we can't learn anything about those. F double prime doesn't tell us about the local max and local min. So it doesn't tell us anything about that. F local max and local min, remember that those are first derivative tests. It's when F prime changes from positive, negative, negative, positive. What's that? These are completely unrelated questions. Completely unrelated questions. These are all different, okay? So remember the definition for F double prime for concave up is when F double prime is greater than 0, and concave down where F double prime is less than 0. And inflection is where F double prime changes negative to positive or positive to negative. Go ahead, take a gander with your friend next to you, see if you can state where it's concave up, concave down, and the x values for inflection. Talk to your friends. Go. I'm sorry, -3. Sorry. The -3 mark is what we want. Yeah, yep. Yes. There's 2 changes there and there. Okay, eyes up here. In green, that is where F double prime is positive. In black is where F double prime is negative. So therefore, F is concave up when F double prime is positive. You should have negative infinity to -3 union forward to infinity. That's where this graph is positive, so therefore F is concave up at that spot. F double prime, when is it negative? It's negative from -3 to +4. So what are the points where you change from concave up to concave down? So -3 and 4 are where your inflection points happen. Those should always match up with this up here. See what I'm saying? Like, these are connected together. Got that? Okay, so flip it over. Classic example. Okay, give you 40 seconds, 45 seconds to read it and talk about a solution with your peers around you. Try example 2. This is question number 80 from the 2012 AP exam. Straight from that, see what you can do. Okay, let's go through it one by one. Okay, my good friend Hattie is worried that she might not get this problem right when she sees the AP exam. And trust me, you're going to see this about 5 more times. You guys will come to a point where you say, yes, I'm going to get that one correct. Let's go through it bit by bit. A local minimum. Can somebody tell me for a, well, first of all, which graph am I given? Am I given F, F prime, or F double prime? Which one is this? This is F prime. And I know that a local min happens when F prime changes from positive to negative. Does F prime change from positive to negative at -3? Changes negative to positive, right? So actually there's a local max at local, I'm sorry. A local minimum is where F prime changes from negative to positive. Does it change from negative to positive? Yes. So that tells us for sure that there is a local minimum there. Okay? Let's go to the next one. The graph of F has a point of inflection at x equals -2. Remember, inflection is where F double prime changes from negative to positive or positive to negative. So if you're looking at the graph of F prime, what would we draw to show F double prime? A tangent line. At -2, do my arrows change from positive to negative? They're always positive there, aren't they? So this one is false. The graph of F is concave down for 0 to 4. So concave down, what's the definition of concave down? F double prime is less than 0. So I'm wondering, where's the second derivative negative? They're saying from 0 to 4, it's negative. Is the second derivative negative at that spot? Yeah, it is. So it is concave down during that time. So 1 and 3 is correct. Third. So this information tells us about F. Yep. Yes. Okay, you saw a nice introduction. Try this one. You'll feel more confident. Hattie's going to get this one correct. I promise. Go. Five, four, three, two, one. This is a question we'll get on the exam. This was problem 85. Same type of question. On this one, they allowed you to use your calculator. You don't need it. You saw F prime. And you said the graph of F prime is given. The function F has a local maximum where you hopefully said a local max happens when F prime changes from positive to negative. You said, well, this is F prime. It changes from positive to negative at x is equal to 1. Last example. I'm going to give you a hint here. What is the graph that they give you? F double prime. What does F double prime tell us about? Not local max or local min. Concavity and inflection. Go ahead. Take 50 seconds. Read it. See what you can talk about. See what you can figure out. Go. Okay, let's look and see what you got, okay? I'm given a graph of f double prime, okay? Graph of f double prime, second derivative. F double prime from -2 to +4, from this spot to this spot. What are all the intervals on which the function f is concave down? So I'm wondering when f double prime is less than 0. So where is f double prime? If that's the function I'm given, where is it below the x-axis? And that will be there, and that would be here. So we're looking from -2 to -1, and then from 1 to 3. That's our result. So this segment, the function is sitting, the f double prime is sitting below the x-axis from here to here. So to be clear, this right here is the same thing as, -2 to -1, union 1 to 3. So that means the same thing. Okay? Question. Yeah, exactly. If it had an arrow, then we would say -infinity. They won't try to confuse you that way on the exam. I've learned that. First time I did this, I looked for a -infinity right away, and I didn't see it. But without a doubt, they stop you there. Okay? So that's the last example. Okay, last piece before I send you on your homework, I just want you're kind of wondering in your mind right now, what are you going to see on the AP exam? And here's what you're going to see. Okay, it's going to start off with 28 multiple choice questions, and there'll be no calculator. And there will be the questions just like what we've done. I'm trying to show you the questions where you feel like you can have a good shot at it. There's going to be other questions where you say, I'm just going to have to guess and move on because that one's not happening. You're going to get about 1.5 hours, hour 15 minutes, something like that for those first 28. Then they'll have you take out your calculator, and you'll have 17 questions, and you'll get, I don't know, it's somewhere between half an hour and 45 minutes, something like that for that section. That's a multiple choice, and that is 1/2 of your overall score. You'll then move on to the free response. You get 30 minutes or a half an hour to do 2 questions that involve your calculator, and then you're going to have 1 hour to do 4 questions that involve no calculator for the free response. Now you're wondering maybe what a free response question is like. You remember how we did those whole like velocity and acceleration and distance type problems? That would be an example of what they have.